tech enthusiasts? It's Dany, and you're tuned into Dany on Tech. Today, we're diving into the world of artificial intelligence to tackle a question that's been buzzing in the tech community. What's the difference between deep learning and machine learning? These two powerhouses of AI have been revolutionizing how we solve problems in the digital age. But what sets them apart? How do they tackle complex challenges differently? And most importantly, which one should you choose for your next tech project? In this episode, we'll break down the basics of machine learning and deep learning, explore their strengths and weaknesses, and look at some real-world applications. By the end of our chat, you'll have a clear understanding of these technologies and be equipped to make informed decisions about which approach might work best for your needs. So grab your favorite beverage, get comfy, and let's embark on this exciting journey through the landscape of AI problem-solving. Welcome to Dany's podcast on technology. I'm your host, Daniel Parente, here to talk all things tech and keep you plugged into the latest innovations and trends on the market. As professional writer and professor in the field of technology, my goal is to break down complex technology topics into bite-sized discussions for everyone. I'm thrilled you are along for the ride. Grab a snack, settle in, and let's have some fun. All right, let's kick things off by laying down some groundwork. Both deep learning and machine learning fall under the big umbrella of artificial intelligence. They're all about creating smart machines that can perform tasks that usually need human brain power. Let's start with machine learning. Think of it as the seasoned veteran in the AI world. It's been around for decades and forms the backbone of many AI applications we use every day. At its core, machine learning is about teaching computers to learn from experience, kind of like how we humans learn. Imagine teaching a kid to recognize animals. Instead of telling them about every single feature of each animal, you show them lots of pictures and let them figure out the patterns. That's basically how machine learning works. We feed data to algorithms and let them discover patterns and make decisions based on what they've learned. Machine learning has found its way into all sorts of applications. It's working behind the scenes in your email spam filter, in the product recommendations on your favorite shopping sites, and even in weather forecasting systems. Now, enter deep learning, the new kid on the block that's been making waves in the AI community. Deep learning is like machine learning's cooler, more sophisticated cousin. It takes inspiration from how our brains work, using artificial neural networks with multiple layers to process information. That's where the deep in deep learning comes from. If machine learning is like teaching a student to recognize patterns, deep learning is like raising a child who not only recognizes patterns but also figures out on their own. What details are important to pay attention to? This ability to automatically extract features from raw data is what sets deep learning apart and makes it super powerful for tackling complex problems. Deep learning has achieved some pretty remarkable feats. It's the technology behind facial recognition in your phone, voice assistants like Siri and Alexa, and even self-driving cars. So how do these two approaches solve problems differently? Let's break it down. Machine learning typically follows a more structured approach. First, you gather relevant data for your problem. Then, human experts identify important characteristics in the data. We call this feature engineering. Based on the problem and the data, you choose an appropriate algorithm, train it on your data, test it, and then deploy it to make predictions or decisions on new data. Machine learning shines when dealing with structured data and well-defined problems. It's great for tasks like predicting house prices, classifying emails as spam or not spam, or detecting fraudulent credit card transactions. Deep learning, on the other hand, takes a more autonomous approach. You start with raw, unprocessed data, could be images, audio, or text. Instead of feature engineering, you focus on designing a neural network architecture that fits your problem. Then you let the network loose on your data, allowing it to learn both the features and the patterns all on its own. Deep learning excels at handling complex, unstructured data. It's the go-to technology for tasks like image and speech recognition, natural language processing, and even playing complex games like chess or Go. Now let's talk about some key differences between these two approaches. First up is their appetite for data. Machine learning can work with smaller data sets. We're talking thousands of examples. Deep learning, on the other hand, is a data-hungry beast. It really shines when you feed it massive amounts of data. Think millions of examples. Next, let's consider feature engineering. In machine learning, human experts need to identify important features in the data. Deep learning automates this process, learning relevant features all on its own. When it comes to computational power, machine learning is less demanding. You can often run ML algorithms on a regular computer. Deep learning, especially for big projects, often needs some serious hardware muscle, like powerful GPUs. Interpretability is another key difference. Many machine learning models are relatively easy to interpret. You can often trace back why the model made a particular decision. Deep learning models, with their complex layers of neurons, are often seen as black boxes. It can be really hard to explain why they made a specific decision. Training time is also a factor to consider. Machine learning models often train faster, which allows for quicker experimentation. Deep learning models, especially large ones, can take days or even weeks to train. So how do you decide which one to use? Well, it depends on your specific situation. Consider things like, what kind of data do you have? Is it structured like a spreadsheet or unstructured like images or text? How much data do you have? Thousands of examples or millions? How complex is your problem? Is it a straightforward classification task or a complex pattern recognition problem? What resources do you have? Do you have access to powerful computers and time for long training periods? Do you need to explain how the model makes its decisions? If you're dealing with structured data, have a well-defined problem, and need interpretable results, machine learning might be your best bet. If you're tackling a complex problem with loads of unstructured data and have the computational resources to spare, deep learning could be the way to go. In the real world, we're seeing both these technologies make a big impact. Machine learning is helping banks detect fraud, businesses predict customer behavior, and weather services forecast the weather. Deep learning is powering speech recognition and virtual assistants, helping doctors spot diseases in medical images, and teaching cars to drive themselves. As we wrap up, it's worth noting that the line between machine learning and deep learning is becoming increasingly blurred. Researchers are developing hybrid approaches that combine the strengths of both. We're seeing exciting developments in areas like transfer learning, automated machine learning, and explainable AI. The bottom line is both machine learning and deep learning are powerful tools in the AI toolbox. Each has its own strengths and weaknesses. As these technologies continue to evolve, they'll work together to solve increasingly complex problems, pushing the boundaries of what's possible with artificial intelligence. Whether you're detecting spam emails, translating languages, or teaching cars to drive themselves, understanding the differences between machine learning and deep learning is key to choosing the right approach for your AI challenges. Remember, there's no one-size-fits-all solution in the world of AI. The best approach depends on your specific problem, data, and resources. So next time you're faced with a tricky problem, take a moment to consider whether machine learning's guided approach or deep learning's autonomous learning might be the best fit. And that's a wrap for today's episode of Dany on Tech. I hope this deep dive into machine learning and deep learning has been helpful and maybe even sparked your curiosity to learn more. If you enjoyed this episode, don't forget to like, subscribe, and hit that notification bell so you don't miss out on future tech talks. And hey, if you have any questions or topics you'd like me to cover in future episodes, drop them in the comments below. Until next time, this is Dany, signing off. Keep exploring, keep learning, and who knows? Maybe you'll be the one to develop the next groundbreaking AI application that changes the world. Catch you on the flip side. And that wraps up another fun and hope-interesting episode of Dany's podcast on technology. As always, hit subscribe and ding that notification bell to join me next time. I had a blast geeking out over today's topic with you all. Feel free to connect on social media with any questions, comments, or suggestions for future episodes. I can't wait to connect more in the comments and bring another dynamic technology conversation your way soon. Until next time, my fellow tech heads, this is your host signing off. Stay curious and keep looking forward, my friends. The future awaits.